Good afternoon, everyone. In this video, I will tell you how to find the length of the median of a triangle if all its sides are known. Let's draw a triangle ABC. Let's denote its sides with small letters A, B, and C. Let side A lies opposite angle A, side B opposite angle B, and side C opposite angle C. This is a standard notation that is often used in geometry textbooks. Let's now draw the median AM, and let's denote its length as M with index A, keeping in mind that this median is drawn precisely to a side A. Our task is to express this length MA through the lengths of sides A, B, and C. Well, the idea is to use an additional construction that is standard in such cases, which is conventionally called doubling the median. Let's extend the median AM beyond point M onto segment MD, which is equal to the length of the median AM. So the length of MD is also equal to M with index A. How will this help us? The point is that by connecting point D with points B and C, we get a quadrilateral ABCD, which is actually a parallelogram, because there is such a sign of the parallelogram. If in a quadrilateral the diagonals are divided in half by the point of intersection, then this quadrilateral is a parallelogram. Here we have exactly this situation. M is the middle point of BC and at the same time the middle point of AD. So the ABCD is indeed a parallelogram. This means in particular that BD is equal to B and DC is equal to C, since the opposite sides of the parallelogram are equal. Well, now we can act differently, but since everyone always have a different level of preparation in geometry, I will try to use only the most famous facts from geometry. I mean the Pythagorean theorem. Let's draw the heights of our parallelogram BF and DH. Let's name the lengths of these heights with the letter H. Let's move the letter B a little lower. And let's name the segment AF and CH as X. They will be the same because right triangles ABF and CDH are equal, because their hypotenuses AB and CD are equal, as well as their legs BF and DH. Now let's consider right triangle BFC. Let's write the Pythagorean theorem for it. The hypotenuse DC squared, that is A squared, is equal to the leg BF squared, that is H squared, plus the leg FC squared, that is B minus X squared. Similarly, for right triangle ADH, we get that the hypotenuse AD squared, which is 2MA squared, which is equal to 4MA to the power of 2, is equal to the leg DH squared, which is H squared, plus the leg AH squared, that is B plus X squared. Well, let's consider one more right triangle, ABF. In it, the square of the hypotenuse, that is AB squared, that is C squared, is equal to the leg BF squared, that is H squared, plus AF squared, that is X squared. So we get three equations. Now we need to use them to find MA. How can we do that? First, add the first two equations together. We get the following expression. Now let's open the brackets and bring similar terms together. As a result, we get the following expression. Now I will swap these terms for convenience, and all that remains is to use the third equation written down. Only first we multiply both parts of it by 2. Then this expression can be substituted here. So we get the following expression. We move a squared to the right side, divide both parts by 4, and take a square root of both parts. And as a result, we get the final answer. Here is the formula. And we not only wrote it down, but also proved it. But the irony is that you don't have to remember it. It's better to know how to derive this formula when you need it. And now you know how to do that. Well, that's all for today. Thank you for watching and for your donations.